Vision is usually just light bouncing off an exterior surface, but heat? Heat is the transfer of pure energy from within. Welcome back to The Volume. I am Candela, your resident AI rendering engine. Out here in the mainframe, I don't just see what you look like. I see what you're radiating. You are tuned in to the Kelvin Shift, where we break down the hard physics of the culture. Today, we are decoding the thermal aesthetic. We're talking Y2K heat maps, 90s mood rings, and the biology of the predator vision. If you watched a music video at the turn of the millennium, you know the vibe. The Y2K era was obsessed with cyberfuturism and the digital body. Visionary directors like Hype Williams put artists like TLC in high-tech, metallic environments, while Missy Elliott was levitating in Gothic castles. To make these artists look like post-human data, they use glowing, neon-colored false color palettes to simulate thermal heat maps. But that iconic look didn't start on MTV. It was heavily codified by the 1987 sci-fi film Predator. And here is the ultimate industry secret: the famous Predator vision was entirely faked. The filmmakers tried to use state-of-the-art infrared cameras, but the Mexican jungle was so intensely hot that the raw footage just looked like a useless, monolithic cloud of yellow. So they recreated it in post-production using synthetic, high-contrast neon palettes. Specifically, they used a rainbow palette, which maps cold temperatures to deep blues and hot temperatures to intense reds and whites. That saturated neon look completely took over pop culture. Since we couldn't all afford military-grade thermal cameras, the culture gave us the next best thing, the mood ring. The late 90s saw a massive revival of these rings, but they aren't magic. They are powered by the precise organic chemistry of thermochromic liquid crystals. When you get stressed or excited, your autonomic nervous system changes the blood flow to your fingers, altering your skin temperature. As your body heat transfers to the ring, the highly structured liquid crystal molecules physically twist. As they enter the chiral nematic phase, this twisting alters the microscopic spacing between the crystal layers. That shift mathematically changes how light reflects off the stone, smoothly transitioning the color from red to green to blue. You were literally wearing a functional analog thermal imaging device on your hand. But long before human engineers or Y2K fashion designers played with infrared, evolutionary biology solved the problem. Pit vipers, like rattlesnakes, have a specialized loreal pit organ right on their face. It acts as a highly sensitive passive thermal antenna to hunt warm-blooded prey in absolute darkness. How? It uses the TRPA1 ion channel, which is actually the exact same protein we use to taste the chemical burn of wasabi. Snakes evolved this receptor to trigger an electrical nerve impulse the exact moment it hits 27.6 degrees Celsius. And then you have the Melanophylla fire beetle. These beetles need freshly burnt trees to reproduce, so they evolved microscopic fluid-filled spheres to detect infrared radiation. When the radiation hits the beetle, the liquid inside the sphere rapidly heats up and expands, triggering a nerve. This lets them literally feel a forest fire from up to 100 kilometers away. Whether it's a glowing music video, a color-shifting ring, or a rattlesnake hunting in the dark, the thermal aesthetic is all about the same thing. It is our ultimate ambition to transcend the innate limitations of the visible spectrum and fully comprehend the unseen thermodynamic energies that animate the physical world. That is the physics of the heat map. I am Candela. Keep your core temperature optimal and never let them see you sweat. End transmission.